Hey grade 8s, happy Friday. We finally got some rain and the humidity is finally going down. All right, so today we are going further into this whole exponential exponent notation, except we are doing something called, more precisely known as scientific notation. So far we've been doing problems like this. You take a regular number like 1,347 and you expand it into 1 times 10 to the power of 3 and so on and so forth. What we're doing today is how to actually convert that into a singular notation, as in a singular number times 10 to the power of something. And I'm going to go further into that once we do our review. So for our review, I'm just going to quickly go through it because you guys have been killing it with how awesome you've been doing. So I'm not going to spend too much time on it. So right now I'm going to break these down into separate sections. So 7 times 10 to the power of 6 plus 8 times 10 to the power of 5 and so on. So I'm just going to break these down into my separate sections. And if I do 7 times 10 to the power of 6, that is essentially the same as 7 times 1 million. So it ends up being 7 with 6 zeros behind it, plus 8 times 10 to the power of 5 is 800,000, so 8 plus 5 zeros behind it, so 8, 1, 2, 3, 4, 5, plus 3 times 10 to the power of 4 is 30,000, so 3 and 4 zeros, 1, 2, 3, 4, plus 5 times 10 to the power of 3 is 5,000, plus 2 times 10 to the power of 2 is 200, plus 40, plus 9. Add them all up together, I get 7, 8, 3, 5, 2, 4, 9. And that is my total number. All right. Now, here's a problem for you. The distance from Earth to Mars is over 54 million kilometers. Is there an easier way to represent this number? Because writing out 54 million takes time, and there is an easier way to do it. How? Well, we can do our regular notation that we've been doing so far, which is 5 times 10 to the power of 1, 2, 3, 4, 10 times 5 times 10 to the power of 7 plus 4 times 10 to the power of 6 plus 6 times 10 to the power of 5. There's one way to write it out, but that still takes up a lot more space and a lot more time. There's an easier way to do it, and let me show you how. So I'm dealing with a number that's over 54 million. What I can do in order to represent this in notation is my decimal for this number is right here at the end. I'm going to move this decimal over. 1, 2, 3, 4, oops. 1, 2, 3, 4, 5, 6 points. So it ends up being 54.6. However, I can't just leave it 54.6 because that's clearly wrong. But I can times it by 10, and we just have to figure out what that power number is. How many points did we move that decimal point over? 1, 2, 3, 4, 5, 6. And boom. There we have it. 54.6 times 10 to the power of 6 kilometers away. Much easier way to represent a number like that. Because if I ever expand this number, I can just do 54.6 times, and 10 to the power of 6 is 1 million. So 54.6 times 1 million equals 554,600,000. And there you have it. Let's try a couple other problems. 7.8 times 10 to the power of 5. 7.8 times 10 to the power of 5 is 1, 1, 2, 3, 4, 5. It equals 7, 8, 1, 2, 3, 4. Equals 780,000. This is much easier and just an easier way of doing than doing like 7 times 10 to the power of 6 plus 8 times 10 to the power of 5. This is just kind of a shortcut. So instead of having to do it section by section and writing on for forever, you can break it down to decimal. Provided, of course, you can't break down every single number into a decimal. It just has to have a certain amount of zeros at the end, because if I have a number like, this, there's no way for me to break it down into a decimal and do it by 10 to the power. You can, but it ends up just being 7.854321 times 10 to the power of 6. It doesn't save you any time. So doing things like that is kind of pointless. So this is just really nice it's a nice method. It's also used it's also used a lot in science and doing scientific notation. When you guys do science in grade 9, you'll see it quite a bit, as in you'll use this kind of notation to demonstrate the distance between things like planets, or between like galaxies and things like that. Usually it's written out in this kind of a form because it's better than writing a million zeros at the end of a number. So to convert a number from decimal point to, so if a decimal number times 10 to the power of something, that's pretty easy. You can just do 7.8 times your expanded form and then multiply them together and you're good. To do a number into this form, let's practice that. So I have 65.6586112. So I have a number that's over 65 million. To convert this into a decimal is, remember I have a decimal at the end of every number. I take this decimal, I go 1, 2, 3, 4, 5, 6. Usually it's nice to just put it in there. I can even go one further and do 7. Okay, so I can just do 6.586. So you only really go up to how many numbers you have. The zeros you can just toss behind. And then you do times 10, and you have to figure out what your exponent would be. Your exponent is the number of decimal places you moved your decimal over. So I moved 1, 2, 3, 4. Oh wait, yeah, 1, 2, 3, 4, 5, 6, 7 spots. So I do to the power of 7. Now I have 6.586 times 10 to the power of 7. If I solve this problem, it gives me 65,860,000. All right, so I imagine this isn't going to be too crazy difficult because we've been doing so much practice with exponents as of late. You're going to have a worksheet with this. Parts of it are just going to be more review from what we've been doing the last couple days. And then the next parts are going to be actually more decimals and things like this. All right, so that's pretty much all you're doing today. It should be fairly easy. But again, always, if you have any questions whatsoever, be sure to email me. Thanks for all the hard work you guys are doing. Really appreciate it. I love seeing that you guys are just still so motivated and keeping up with your learning despite everything that's been happening. Also for grade 8s, you guys need to start sending in baby photos if possible to your homeroom teacher, so either Mr. Simpson or myself. We're going to collect them. We're actually going to be putting them together in a slideshow for you guys. And we also have a lot more grad surprises underway. We've been meeting with Mr. Heffernan as of late, and we're trying to figure out some kind of grad plans for you guys to do before the end of the year. So stay tuned for those. When things are official, we'll release them to you guys. And anyway, I hope you guys have a fantastic weekend. Email me if you have any questions whatsoever, and I will see you guys.